let us replace here delta x by h. Now, this becomes dy by dx is equal to limit h tends to 0 f of x plus h minus f of x by h. So, now this is known as first principles. This is called first principles. First principles, or we can call by definition, or we can call ab initio. Ab initio means is a beginning, that means beginning. Fundamental theorem of this is fundamental theorem by finding the derivatives of any function. So, using this formula we can find out the differential coefficients of various functions. This is called first principles or by definition or ab initio. So, one more thing, this dy by dx is also denoted by f dash x or y1 or y dash. These are all called first derivative. First derivative of f of x. Okay, now let us find out the differential coefficients of the various functions. So, let us do. So, first one, let us consider f of x is equal to constant function. C is a constant function. First, let us find out f of x plus h, that also C from first principles. First principles, from first principle. Dy by dx is equal to limit h tends to 0 f of x plus h minus f of x by h. Okay. Now, limit h tends to 0, this is c minus c by h, c gets cancelled, limit h tends to 0, 0 by h, 0 by something is 0, so we get 0. That means here f of x is nothing but y, so here c, therefore differential coefficient of constant function is always 0. So, some examples we can take it, we can note. So, what is the derivative of d by dx of 2? 0. So, d by dx of something minus 5, constant 0, d by dx of pi, that is also constant 0, d by dx of some 2016 is also 0. That means differential coefficient of constant function is 0. More. Let us suppose f of x is equal to x to the power of n. What is the derivative of x to the power of n? N is a real number. So, now first find f of x plus h. This we can write x plus h whole to the power of n. So, now by first principles, dy by dx is equal to, we have the formula limit h tends to 0 f of x plus h minus f of x by h. Now, this is equal to limit h tends to 0, this is x plus h whole to the power of n minus x to the power of n by h. Now, this h can be written for our convenience, limit h tends to 0 x plus h whole power n minus x power n by, this h can be written x plus h minus x. Does it make any difference? No difference. As h is 0, x plus h tends to h. So, now this can be written limit x plus h tends to x, x plus h whole to the power of n minus x to the power of n by x plus h minus x. How does it appear? In limits, already we have discussed, the limit x tends to a, x to the power of n minus a to the power of n by x minus a is equal to n into a power n minus 1. So, using this one, this can be written n into x to the power of n minus 1. Therefore, d by dx of x to the power of n is equal to n into x to the power of n minus 1. Okay, using this result, let us deduce some problems. Discuss. Here the first one, d by dx of x. X means what is the power? 1. So, 1 into x to the power of 1 minus 1. So, x to the power of 0, that is equal to 1. Derivative of x with respect to x is 1. Now, d by dx of x square, 2 into x to the power of 2 minus 1, that is 2x. So, d by dx of x cube, so 3 into x to the power of 3 minus 1, 3x square. Similarly, now d by dx of x to the power of 2016, this we can write 2016 into x to the power of 2016 minus 1, 2015.